Today we'll discuss calculated fields in Insight Plus and some of their basic use cases, as well as the syntax and how they work on data sets across multiple cards as well. So I'll go into Insight Plus in my Tempus environment, and I'll start by just creating a new card using one of our data sets. Let's just use assignment allocations because it has a broad range of data for me to perform calculations on. And now that we're in the analyzer, I can look on the left side underneath the dataset tile, and we can see all of our beast modes and segments or calculated fields that we have currently available to us on this dataset. We can also make new ones to apply in our visuals. So let's do a really basic table, and I'm going to just pull in some points from the data set to base this off of. So let's pull in some resources and some dates. Actually, let's do this by the current month's date. So I actually won't bring date into the set, but I'll bring the date into the filter on the individual card. And then we'll see all of our resources. And let's just look at named resources. Set this to true. Or false, rather. So now we have all of our non-demand planning resources, so all of our named resources. What I'm going to do is pull in all of their planned allocation hours and actual allocation hours. And what we can do is use a calculated field to find the difference between them. So I can pull in allocation planned work hour. Actually, just let's say work hour, so I can see both actual and planned here. I can bring planned and just drag it into the table and actual. And I'm going to change these into sums so that we get groupings per resource. And now we can see that Angela Tucker, for example, has 115 planned hours, but no actuals. So let's find anyone who has actual hours so we can get a good use case here. Let's use Amy Jacobs. So I'll just filter on Amy Jacobs so we can see how this works. So overall, across all of her allocations, I'm no longer limiting it to a date. We're looking at 14,000 planned hours and 263 actuals. So maybe she has planned hours well into the future, and is only now just starting to either have actuals allocated to her or be filled in via timesheets. If I wanted to find a comparison between these two, there's not a way to just easily do it using the columns. I have to make a calculated field. So I'll press the button on the bottom left, and we go into the calculated field window. We can see all of our dimensions and measures and calculated fields on the left side like normal, but we can also see a functions portion. This uses MySQL as a foundational language, so you can use things that aren't even within this window, but for the sake of simple calculations, we can just use these. We have common ones such as min-max sum, counting. We have aggregates such as count distinct, fixed functions, as well as sum distinct, etc. We have mathematical. So if we needed to perform a mod division, if we needed to do something to the power of something else, round it, etc. Logicals, so case statements, case if A happens, then we do B. If B happens, then we do C. If C happens, then we do D. Else we do E, for example. We also have string functions, so if we need to concatenate or manipulate strings in some way, find within the string certain values. And then we can also do date time functions as well. But again, bringing this back to the use case, we want to compare planned hours to actual hours. So what I'm going to do is very easily say allocation planned work hour, and I can press tab and it autofills it, minus allocation actual work hour. And what this will do is give us how many remaining hours this individual has planned compared to what they've actually fulfilled. And this can be useful if we, for example, want to see if we are correctly allocating someone, and if, as trends are concerned, we have given them the appropriate amount of planned hours that satisfy the actual work that they would be performing. But we can just call this planned actual variance, and maybe we say hours. We can validate that this formula is correct syntax-wise, or we can also save it to the data set. And I would recommend doing this for all calculated fields that you do, unless you only wanted to appear on that individual card. If it's maybe a calculation that has some sort of sensitive data, or maybe you need some plain text that you don't want to be on the entire data set for whatever reason. Otherwise, I would say typically you'll want to save it as a calc to the data set, because then it will be referenceable by other cards that use the same data set, such as all of these are appearing by default for me. So I've validated that it's correct. I've ticked that I want it to be saved on the data set, and now I can create the calculated field. And if I collapse these, I can see the value here, planned actual variance hours, and I can drag it in just like our other fields. Now, because it is a non-grouped function, all we're going to need to do here is treat it like any of the other fields and also sum it. And now we can see the sum of our planned minus the sum of our actual equates to this sum here, which seems to be correct here, about 14,100 as opposed to this value. If I, for example, said something more like this, sum of allocation planned minus sum of allocation actual, and I save it, we don't have the ability to aggregate this anymore because we've specified what aggregation we're using in the calculated field. Another very typical use case you'll find is case statements. Perhaps we need to evaluate just in a simple filter whether or not an individual maybe starts with a certain value. Maybe you're prefixing your resources with a certain character that you need to have be available for filtering. Or maybe you only want to have the sum of Amy's allocations against the entire allocation base. There's a lot of different use cases that you could apply, but for now, I just want to quickly show how we could use a case statement. And I'm going to unfilter resource names so that we can see everybody here, and create a calculated field using a case statement to do something similar that is a little bit more versatile. So a case statement always functions as case when A, then B, else C, end. So we just need to start filling in these. We can say when resource name is equal to Amy, I think it was Jacobs, then B. Then we can say 1, for example, else 0. And calculated field, let's just say Amy Jacobs filter. I'm not going to save this one on the data set because it's fairly particular to this card, and I'll create this here. So we have our Amy Jacobs filter saying if the resource record is Amy Jacobs, then 1, else 0. And when I drag this into our table, we can actually see everyone else has a 0, Amy Jacobs has a 1. And what we can do is actually also drag it into the filter. And we say, is 1 apply? And now we only see Amy Jacobs as we're doing this filtering. So I can also take this and apply it, for example, let's say I want to find Amy Jacobs' percentage of planned hours out of my entire planned hour workbase. So we know that she has about 14,000. Let's remove this so it ungroups everyone. And remove this sorting so that it groups everyone. So we have 1 million or so planned hours. I can now do something with this filter where I say, maybe we just want to look at Amy Jacobs as a fraction of our entire resource base. And so all I need to do is, let's say, Amy Jacobs hour percent. And we can say case when a resource name is equal to Amy Jacobs, then planned allocation planned work hour end. And what this is going to do is retrieve all of Amy Jacobs' planned hours. So we can sum this on the outside. And now that's going to aggregate it. And now I can say divided by sum case. Actually, let's just do the entire allocation planned hour workbase. So what this is doing is saying, how much is Amy Jacobs' hours out of our entire allocation hour workbase? I won't save this one on the dataset yet again. Create the calculated field. And I think I can just drag it in here. So if I do Amy Jacobs hour percent, and I can increase the number of decimals via the formatting, display as number, decimals 6. So this quite small number. Pull up a calculation just to validate here. 1203, 123. No, hold on. Let's do 14,300 divided by 1203, 123. And you can see that that percentage about matches up, excluding these decimals. So we could also apply something similar to an entire department. So if we wanted to say, let's not just look at Amy Jacobs as a fraction of our entire hour base. Maybe we want to look at an entire department, maybe when department equals engineering. We retrieve all of the engineering department's allocations as a fraction of our work base. And then we could maybe have a dashboard that compares multiple different departments using similar calculated fields. So those are the sort of use cases that we really typically see using calculated fields, is basic comparisons as well as logical evaluations to create more robust reporting. In the next video, I'll talk about more advanced use cases, as well as some more robust MySQL functions, for example, some window functions, as well as level of detail fixed calculations that can also be quite useful as well. So thank you for watching.